Hello class, and welcome to lesson 5.4, evaluating polynomial functions. We can evaluate the function in different ways. One, by substituting in the given x value and find the y. Two, by using a graphing calculator. You can either use the table or the value button from the calculate menu. And if you're using the graphing calculator, please make note of these pages in your textbook, 94 and 95, for the keystrokes to use. Let's start with our first example here. It says evaluate f at x equals x cubed minus 2x squared plus 3x minus 10 for the following values. So for A, we're going to say x equals 2. So all you're going to do is wherever you see an x, you're going to replace it. So function notation says instead of f at x, we're going to put f at 2 equals 2 cubed minus 2 times 2, that's the substitution one right there, squared, plus 3 times 2 minus 10. Okay. Doing some mathematics, 2 cubed is 8, and 2 squared is 4, times negative 2 is minus 8, plus 6 minus 10. These two cancel, so we're left with 6 minus 10, which is negative 4. What does that mean? That means that this point, when x equals 2, y equals negative 4, is on this graph. Okay, so I'm just going to write that down. So therefore, point, a short form for point, 2, negative 4 is on f at x. All right, let's do the second example. Okay, using the same equation, we're going to sub in negative 3. So f at negative 3 equals negative 3 cubed minus 2 times negative 3 squared plus 3 times negative 3 minus 10. Subbing that in and doing some, we've subbed it in, now we're going to do some calculations. So you're going to get negative 27 minus 18 minus 9 and minus 10. Put that all together. They're all negatives, so you can add them and put a negative sign. Negative 66. So what does that mean? When x equals negative 3, y equals negative 66. Or point negative 3 and negative 66 is on f at x. All right. Any questions with that? That's a straight substitution, and make sure you're using function notation where you show the substitution. All right, let's move to the next page. All right, so now we're going to take a look at what we call y-intercepts. So the y-intercept occurs when x equals 0. On a graph, it's where the line crosses or the curve crosses the y-axis. Remember, this is your x, this is your y. So in this graph case, you're going to have when x equals 0, y equals 2. So therefore, y-intercept is 2. Okay, or you could just say y equals 2 would be fine. When I ask you to determine a y-intercept of a function like this, remember we have to remember the y-intercept occurs when we let x equal 0. So what we do is we sub this in and do function notation. So instead of f at x, we're going to go f at 0. So wherever we see an x, we replace it with 0. Okay? Easy for us, ladies and gentlemen, is the calculations when you've got 0 and you're trying to cube it or square it. That's 0 plus 0 minus 7. So all of the terms that have a function or have a function variable, meaning the x in it, will turn to be 0. So f at 0 equals negative 7. So therefore, y-intercept equals negative 7. Okay? So how would you determine the y-intercept without doing the calculation? Well, first of all, notice in this past example, the one that I'm just going to circle right up here, any term that has an x in it will become 0 when you try to do the substitution. The only thing you need to look at is the constant. Okay? So what you need to do is look for the constant. And just remember, the constant is the number all by itself. Okay? All right. Because and you make sure all other terms will equal 0 because of the substitution. All right. Next page. Now we're going to take a look at a rectangle question. What's the information given? The width of a rectangle x and the length is 4x plus 5. Write an equation for the area with reference to x. So again, we know area equals length times width, but we're just using function notation. So area with respect to its width, okay, that's going to equal, what we think about is going to be length times width, or in this case, that equals width times the length. I like doing that one better. Okay, now I sub in what I know. My width in this case is x. Okay, and I times it by the length, which is 4x plus 5. Now the reason I did this, ladies and gentlemen, is because I like to do my distributive law with the x out front. So what does that equal? 4x squared plus 5x. All right, just going to have to pause the video for a quick second, and I'll be right back. Hi guys, I'm back. Sorry about that. Just had to make a correction on my paper. So if you don't have this correction here, change that to 854. All right, for B, what is the area of the rectangle when x equals 10? So remember, we know a at x from our question in A equals 4x squared plus 5x. So we're going to see wherever we see a x, we're going to put a 10. So it's going to be a at 10 equals 4 times 10 squared plus 5 times 10. Doing some calculation, that's 100 times 4, which is 400, plus 50, so that equals 450. So therefore, area is 450 units squared. They didn't specify, so just go units squared when x equals 10. All right. Now it says to use technology to determine the value when the area is 854. I'm going to show you two different ways. One, we can use the table of values. And two, we're going to take the graph and find the point of intersection. Okay? Because we know this is a quadratic, so we're going to use the quadratic, and then we're going to put a line, which is y2 equals over the area 954. All right? We may have to change our window, but let's take a look. So I'm just going to use a graphing calculator I've popped up. You can use any online graphing calculator, including the one that's on my Math Tools page. Okay, so if I go to y equals, I put my equation in, folks, and you can see the graph on this screen as well. Okay, and if I need to find, the question said find the value of x when the area is 854. I use my table, so I go second table, second graph, and hopefully yours isn't right on the spot, so you're probably starting somewhere near here, and you keep scrolling. Your area is in your y1 column, and notice here, guys, that when we have 14 for x, our area is 854, so I'm just going to snapshot that, hopefully. It'll be nice, and let me snapshot that and take that into our lesson. Okay, so let me put it in there and see if we can drag it right in. Okay. So there's our first example of how to do this. Our second is using the graph, okay? So this is from the table of values. And here you can find right here. So therefore, x equals 14. Okay? Now we're going to do a point of intersection. So if I go back to my graphing calculator, I go to my graph. So I go to y equals, I keep my first equation in. I'm going to put my second one in, and I'm going to put the value of the area in. So it'll be a straight line. So I'm going to do an intersection. I'm going to do an intersection between the parabola and the other one. However, ladies and gentlemen, it is not it's not working right now because I got to fix my window. So let me go to window, and I'm not going to worry about any negative values. I'm going to take that. I'm going to take that to, I don't know, 18 might work. Okay, so for my area, go 0, and let's just go 900. Graph. See if that looks better now. Okay, so notice there, ladies and gentlemen, this is, I've got here the curve of our expression, okay? And then here is our area limit. So we want to find this point of intersection right here. So to do that, I go to my calculate menu, which is second trace. I find the point of intersection, which is 5. I'm just going to clear this up so you guys can see it. It says first curve. Make sure that your cursor's flashing on one of the curves. You press enter. It'll flash on the second curve. Enter, which means, hey, we want to find the point of intersection. It says to guess. And notice there we've got the intersection point for finding the area. So the area is 954 when x equals 14. Now let's see if I can quickly capture that and drag it into our notes as well. Isn't it fun having the technology, guys? I know some of you are like too crazy, but anyway. Okay, so this is method 2 with the point of intersection, P of I. Okay, so you go to the calc menu. To get there, it's second trace. And then press 5. Okay, and you go enter, 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 and you'll get it. All right, taking a look at our last example, it says use the graphing calculator to evaluate y equals 3x to the 4th for x equals 6. Okay, so what we're going to do is go back to the graphing calculator. Okay, so flip back. I'm going to go clear this off for you guys. I'm going to press the clear history. I'm going to go y equals. We're going to clear that. Down arrow clear. So I got everything cleared off. Okay, and then I'm going to put in the equation 3x to the 4th. So I got to go hat 4. Okay, and I press graph. See if it comes up there. I can make my window a little bigger. Okay, so let's just make our window a little bigger. So I just need to go to 10 for this one. And let's go 4,000 for this one. Okay, and we're going to go graph. Okay. So that's what we have, and then we need to find out when does, okay, question is x equals 6. So we're going to use the value menu in the calculate portion. So you go second trace, which is calculate menu, hit value, hit enter, x equals 6, enter, it'll say, it actually gives it to you, sometimes it'll say guess, okay, and so we will copy that quickly into our screen. And there you have your answer. Okay, just quickly we could go back and I could show you on the table, ladies and gentlemen, if I get the table up. Okay, You could just go left and right until you also see that as well. So there's a second possible method. And I'll snapshot that since we're here. Another way to do that. As long as you explain your method, I have no problem, guys, with which method you want to use. Okay? All right, ladies and gentlemen. Again, use technology that's available for you. I'm sure when you get to college, university, you're going to be using it as well. Here's your homework for today, page 96, 97, number 5, 7, 1 and part 5, 12, 13 AB, and 15. Have a great day. See me if you need help, especially with the graphing calculators, okay?